Okay, we're going to pick up with proteins, you guys, in chapter 3. And got to just draw on the board what you're already used to. This is an amino acid right here. And remember last time that we talked about this R group. The R group is variable. So remember that, that table. I'll look it up so I can guide you right to it. Figure 3.20 on page 47 shows all of this stuff. And, of course, on this side, the amine group, right? So that's an amino acid. This is going to be the building block, the fundamental building block for proteins. We're going to take it from amino acid to chains of amino acids formed through dehydration synthesis. And then we're going to have that chain. Remember the candy necklace that I was talking about the other day? And we're going to start to see higher order changes of the chain, shape forming changes. And we're going to go through several structure levels. The first one's going to be secondary structure, the next one tertiary structure, and then finally quaternary structure. And by the time we're done with that, you should have a pretty good understanding, at least on kind of a big picture scale, of what proteins are. So this is our amino acid. If we draw another one right next to it, like this, another R group. So we got that. You always know that that looks like water to me. So the process is that very familiar process that we've talked about before. If we form an amino acid, if we join two amino acids together, we're going to do it by dehydration synthesis. Of course, if I had a classroom full of you guys right now, I'd ask, what's the opposite? What's the breaking of a bond by the addition of water called? And of course, all of you are saying right now that that would be hydrolysis. So, right? Dehydration synthesis one way, hydrolysis the other way. So we have that, and then we end up with this, of course. So, keeping it as quickly as possible. And of course, this guy right here, we're going to call that something very special. This is the peptide bond. That's the peptide bond. And what we're going to do when we make long chains of these things is form something called a polypeptide. So let me erase here. All right. I'll leave the bottom in case you haven't caught up yet. So this whole process is going to form what we call and define as a polypeptide. Okay. So the poly part here, whenever you see this in a Latin term, in a scientific term, it's going to mean many. So here we have many peptide bonds. And what I want to do now is change gears and convert our concept of polypeptide as a form of structural formulae into this cartoon that we'll work with from now on. Our cartoon is going to be kind of a string of pearls idea, or candy necklace, right? And if we start off, and pick some colors out here, of course we have a whole bunch of different colors of amino acids to throw in here. Who knows what we would end up with? I'm just showing you that a sequence of different kinds of amino acids is going to make a beautiful polypeptide. You guys don't have to try to figure out those colors, but that shows a cartoon of a polypeptide made of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 different amino acids. When it comes to protein, we call the sequence of amino acids its primary structure. So that's my next big definition, the primary structure of a protein. Of course, I'll put in parentheses here, of a protein would be equal to the specific sequence of amino acids. And I'm going to start using AAs, as I told you before, to represent amino acids from here on out. So that'll be our little shorthand. All right. So there we have it. The primary structure of a protein is going to be some order of amino acids that are stuck together. And I want to keep referring back to this table, or excuse me, it's a figure 3.2 on page 47. And you can see that there's a pretty good diversity of amino acids from which to make this candy necklace, so to speak. So peptide bonds, different amino acids, that's the primary structure. The secondary structure happens when something that you're very familiar with takes place, called hydrogen bonding. If you turn the page in your book and you go to page 49, you're going to see something pretty cool in the secondary structure. So there's primary structure. What is secondary structure? So I'm going to say, see page, gotta look, 49. And for secondary structure of a protein, we're going to focus on two things. The first one is what we call the alpha helix. And the second one is what we're going to call the beta pleated sheet. All right. The thing about both of these is that both of these are formed by hydrogen bonding, which I'll just abbreviate H bonding. Of course, this brings me back to that little review. You remember what H bonds are. Starts off with a polar covalent bond on one molecule between an oxygen and a hydrogen. Of course, the oxygen is a lot more electronegative, gets a partial negative. The hydrogen is a lot more positive, gets a partial positive. And then adjacent ones that have that same feature, you can actually have the partial charge of a hydrogen being attracted to the partial negative charge of an oxygen. That right there is a hydrogen bond. And of course, remember when we did it, we drew dotted lines in between those. And of course, the dotted lines don't represent the strength that single lines do. So then you're constantly reminded of the whole strength of chemical bonding. And of course, remember that. Triple covalent number 1, double covalent number 2, single covalent number 3, and then ionic bonding, that weirdo. And then below that, we had hydrogen bonding. So they're pretty strong, but not nearly as strong as covalent bonds. So let's take a look at what these things look like up close and personal. The way that we're going to make an alpha helix is to kind of have this idea that, okay, well, here's our primary structure right here. And I'm using the same color now. So this is basically our primary structure. Oh, by the way, 1 with a degree sign is our symbol now for primary. And of course, on down the line, secondary is going to be 2 with a degree sign. So secondary. So we're introducing all these nice little shorthands. So what's going to happen here in the forming of this is the whole thing is going to take a form of a helix. a corkscrew. So if I draw the line this way first, and then I can actually start to fill in with my little peptides, looking kind of like this. Of course, those ones go over. So on and so forth. If you take a look at a picture in your book, we're just going to be kind of abstract with these. You can see that there are dotted lines here, specific dotted lines between amino acids that are establishing these bonds that make the whole thing coil up. So this is a very regular feature of many proteins, is something called the alpha helix. So hopefully that's cool. I'll give you a few seconds to tighten that up. If you want to see it in the book, I'll make a reference, and that's figure 3.22, page 49. Okay. So that's our first secondary structure, and I guess I'd better do this too. So, as I said, secondary structure. And what happens to make this is the formation of H bonds. Excellent. All right. So now what we're going to do is show another form of primary structure, this time, again, by H bonds, but this forms a different entity. This is going to be what we call the beta pleated sheet. And this one's a little harder to do on the board, so we want to kind of take a first line looking like this and kink it. And make a hairpin and kink it. So that's going to be kind of the backbone of what we're up to here. And then here the same. And then what we'll go ahead and do is fill in circles. The circles are going to represent the amino acids, right? So this is this line that's going to be a template for this. And then all these circles are going to represent kind of this string of pearls that we've made. It goes all the way around. It's nuts. There's a lot of them. I might have... Okay, that's a ton. That's a ton. Then what I'm going to do is take another color here. I'll let you guys get that. So some of these guys are going to be stuck together with our old friends, the hydrogen bonds. Whoops. So certain amino acids are going to stick together, and that is going to produce this bonding. Of course, ours is a cartoon. It doesn't have to be perfect, but that's what's holding everything together, is hydrogen bonds. Of course, just to take a look at this, you know that each one of these circles is an amino acid. So that's an amino acid. Of course, all these are amino acids. And that means that whatever the bond is in between them, whatever the little bond is that's holding those together, that little bond is the peptide bond, right? So we always want to know when we're using a cartoon like this, we always want to know what it really represents. So going backwards, those little spaces between each circle are the peptide bonds, and then each circle is an amino acid. Okay, so hopefully you've got this tight. One of the things I want you to kind of be seeing here is that this is kind of a surface. And then going this way, the surface shifts. So if you know what the word pleat means, this should serve to kind of show you what I'm talking about. Let's do one more right here. Okay? I'll show you one last thing what I mean here. You guys go ahead and fill that in and try to wrap your brain around it. And I will show you one thing that I did before. Okay. While you're doing that, I'll go ahead and label it. This is called the beta pleated sheet. Excellent. Hydrogen bonds and all of that. Okay, you guys see what I did here? I took a regular piece of paper and I drew my primary structure of a protein. I drew my string of pearls, candy necklace, so all those little amino acids with little spaces between. And then what I decided to do to make the sheet is I did these foldovers. And I'll try to hold this up so you can see what I'm doing. This should give you a little bit of three-dimensional perspective on what's going on here. So I'll unfold that, and that's what the beta pleated sheet looks like. See the pleats, you guys? Those are the pleats. That's what we're talking about. And of course, the name pleat, as I used to know it, is actually kind of a clothing term, you know, like a skirt or something, a pleated skirt or pleated pants. But this is the idea. In 3 dimensions, there's actually a pleated kind of surface feature of this arrangement of amino acids. It's amazing. So that's cool. So what we're going to do now is we're going to take these things and these things as part of bigger picture of these things and put those all together, and that's going to end up producing something that's kind of really three-dimensional. And I've got one more little visual aid that I need so I can really show you what I mean there. So I will pause the tape and be right back.